So these are the notes for 16.3. In this section, we're actually going to skip over the first two sections of Module 16, and then we'll jump into Module 17 shortly after, but it mostly just focuses on triangles still and the different shapes of triangles, and eventually moving to similarities. So the first things that we need to talk about are ratios and proportions, and they're very similar. A ratio is a comparison of two quantities. So a comparison of two quantities. And really for us, the big thing is those will almost always look like fractions. Now there are different ways you can write a ratio. If you remember back, I don't know, maybe 6th grade or something, and you used to write 4:5, right? Those are still examples of ratios, but for the most part, we're going to be working with fractions. And a proportion is simply stating that two ratios equal each other. Let me fix that I really quick. So there are some properties when we say that a fraction equals another fraction. The first one, okay, and we're going to use this example here where a over b equals c over d. So I have two fractions that are equal to each other. The first property we can say that if a over b equals c over d, then b over a must equal d over c. So if I flip the first fraction, and I flip the second fraction, they're still equal as long as I flip both of them. The second property is that if I have a over c, so now I'm taking the two top letters here of my fractions and my two numerators and making a fraction out of those two, then I can also make the fraction out of the denominators, b over d. And one thing to notice is that a and b line up vertically in the first fraction, and they line up horizontally. So they're not diagonal from each other. They still have to kind of line up either vertically or horizontally. The third property that we can say is that if I add the denominator to the numerator, so in this case I'm going to add b to the top, that is going to be the same as adding the denominator on the other side. So as long as I'm adding the denominator on both sides, again, we're still okay. And the last one, that fourth one, is actually this down here, and it's something called the cross product property. You've probably already worked with it before, and that's a big property that we're going to use a lot in the next couple units, and that is this. I can multiply across my equal sign diagonally so that those fractions become this equation. A times d is equal to b times c. So if I have two fractions that are equal to each other, you might have heard it as cross multiplying, right? Product is the end result of multiplying, so it's essentially the same thing, but the actual name of the property is cross product property. So we're going to use that here in just a few moments. That's going to be a big one that we use a lot. And so our first example says if x over y equals 5 over 6, so I have a proportion, we have two fractions equal to each other, complete the following statements. For letter A, it says 6x, so 6 times x. 6 times x, if we did that, has to equal 5 times y. Right, as long as I'm multiplying across, we're okay. In letter B, see if I can keep that in the corner there. Again, we're starting with x over y equals 5 over 6. Now I'm saying I'm flipping my fraction y over x. So if I flip the first fraction, as long as I flip the second fraction, instead of 5 over 6, it'll be 6 over 5, we're okay. And then lastly, letter C. Now we've added the denominator. X plus y over y would equal 5 plus 6 over 6. So again, as long as we add the denominator to both sides, we are okay. So we can use those different properties, okay, all those properties of proportions, and we'll be just fine. So now here are some examples. I'm going to do a couple of them for you and then let you do the other couple. So the first one, letter A, solving each proportion. You'll notice there's only one variable. And so the main property we're going to want to use, the cross product. Going to multiply across there, which will give us 7x. Multiply across here. Has to equal whatever 5 times 12 is. So 7x has to equal 60. And if we divide both sides by 7, x equals 60 over 7, or if you want it as a decimal, 8.58 if you round, because it does continue on. Okay, but 60 over 7 is what we would want, and that's letter A. Again, using that cross product property, multiplying across diagonally through our equal sign. So letter B, doing the same thing here. We're going to multiply this numerator on the left times the denominator on the right, and going the opposite direction. So we have 4 times that whole expression, and this is going to be key. You have to put, when there are multiple things up top or down below, you have to put them inside parentheses. Okay, that's really, really important because you have to distribute. You're going to have to distribute, and if you forget those, it's really easy to forget that that's what you have to do. So we have that on the left equals 8 times y. If we then distribute on the left side, 4 times y is 4y. 4 times 3 is 12, equals 8y. We're going to subtract 4y from both sides. So we have 12 equals 8y. Sorry, whoops, 4y. Divide by 4. So y equals 3. So I'm going to let you work on C and D, and I'm not going to go over those simply because if I do that, this video will end up being 45 minutes long, and you guys don't want that. So I'm going to have you guys work on C and D, and if you want me to check it in class, I'd be more than happy to do that and let you guys know what the answers are for those. So go ahead and turn the page. So if two figures are the same shape, but are not the same size, so they look the same but one's bigger than the other one, then we call them similar. Okay, so they might look like they're the same exact shape, but one's bigger and one's smaller, then they are called similar. And this is going to get a little confusing because the sign for that is this little squiggly line right here. Okay, two things that are similar. Okay, we use the little squiggly line. It's going to look very similar to congruent, right? Congruent looks like this with an equal sign and a little squiggly. Okay, but similar is just the squiggly line. So for similar figures, there are two characteristics that are important. The first one is that corresponding angles are congruent. So corresponding angles are congruent. And the second one, and this one is always the hardest to remember, So make a big note of this one. If you want to put a giant asterisk by it, put a giant asterisk by it, highlight it, underline it, do something. And that is this, that corresponding sides are proportional. Okay, the sides are not congruent because the sides are what make them different shapes, or sorry, different sizes, right? If the sides were the same length, then they'd be the same size. Okay, but we just said that they're not the same size, and if they were, then we would call them congruent. Since they're not, we would call them similar. So an example of that would be this. We have this triangle here that looks a lot like the triangle to the right, except obviously one's bigger. Okay, and again, proportional means that if this side is 4, and we say that the triangle on the right is 2 times as big, then that side would be 8. And so if my second side is 10, my second side on the right would have to be 20, right, because it's twice as big. And my bottom side, let's say that that's 15. The right one would be 30. Okay, so they're the same shape, right? They have the same shape because my angles are the same. The angles are congruent, but the sides are not the same size. They're proportional. They have that same ratio, right? 4 times 2 gave me 8. 10 times 2 gave me 20. 15 times 2 gave me 30. But ultimately, they're different sizes. One is smaller than the other. So next, we want to consider the graph of ABCD, which is this kind of inside quadrilateral here, and EFGH. So I've highlighted those red and blue for you. It says, are corresponding angles congruent? Well, if we look at our figure, angle A would match up with angle E, and are they congruent? Well, because of the fact that they're on a graph, we know that those angles are actually 90 degrees. And so since those are 90 degrees, angle A is congruent to angle E. And because of the way this is shaped, you can see that all of those angles are 90 degrees. And again, that's just because of the definition of our grid line of our graph. And so in fact, all of those corresponding angles are congruent. So A matches with E, B matches with F, C matches with D, B is congruent to F, angle C is congruent to angle angle G, and angle D is congruent to angle H. And so again, we know that that's true because all the angles are 90 degrees. Now, are the ratios the same? And so what we're going to do here is we're actually going to figure out how long are the sides and compare them to each other. So AB, if we look at side AB, is 4 units long. And EF is 7 units long. And BC is 3 units. FG 2, 3, 4, 5. Oops. What is happening? There we go. Is 5. And then CD over GH, because of the fact that it's a rectangle, we already know those are going to be the same as the first ones. So 4 over 7 and 3 over 5. Now, are the ratios equal? Like, are all of these fractions the same exact fraction? If you look, the answer is no, right? Two of them are 4 over 7, and the other 2 are 3 over 5. So since those fractions are not equal, the question asks, are they similar? The answer says no, they are not similar. Because these sides are not proportional. So we saw that the angles were congruent, but the sides were not proportional. They did not all have that same multiplier, right? They did not have that same ratio from one figure to the other. So then our next example says determine whether these triangles are similar. If they are, write a similarity statement and give the scale factor. So we have triangles A, B, and C, ABC, and DEF. So hopefully by looking at this here, you notice that angle A corresponds with D, B corresponds with E, and C corresponds with F. So therefore AB corresponds with DE, which is 15 over 20, which if we divide both the top and the bottom by 5 is 3 over 4. Then our next pair of sides is BC and EF, which is 12 over 16, which if we divide by 4 is 3 over 4. And then our last sides are CA and FD, which are 18 over 24, which if we divide by 6 is 3 over 4. So, were my angles congruent? Yes, because we can see in the diagram that they have these congruent markings. And are my sides proportional? Do they all have the same ratio? And the answer is yes, they did. So are these triangles similar? Yes. Triangle ABC is similar to triangle DEF. And our scale factor, the ratio that tells us how much bigger it is that fraction right there. The fraction that all three of them come out to be, since they were the same, is 3 over 4. Now the problem said to write a similarity statement. Okay, that similarity statement is this part right here. Triangle ABC is similar to DEF. So anytime it asks for a similarity statement, that is all you are wanting to write, is triangle this is similar to triangle that, or quadrilateral this is similar to quadrilateral that. And so if we go to the next page, we have our next couple examples of mapping. We're not going to do all of these, but I do want to talk about a couple of them. The first is letter A. It says a figure EFGH maps to figure RSTU. So in a problem like this, since we're mapping to something, this first one is going to be where we start. The second one is going to be where we end. Okay, so we have a starting point and an ending point. And so it says to write a proportion that contains EF and RU. So to write a proportion means we're going to have two fractions that are equal to each other. and there's EF in the first one, and RU in the second one. So the two that it wants me to include, right, there's EF and RU. Those are going to go on opposite corners of my proportion. Okay, so those two that it lists are going to go on opposite corners. And then now we want to see what side corresponds with EF. Well, EF is the first two letters here, so what are the first two letters of my other one? That's R and S. So R and S. And then it asks for R and U, which are the first and last letter on my right one, which means it would be E and H. So there's our proportion. That's all we have to do is write it. It doesn't say to solve or do anything with that. So we're good there. So there's our first answer. Then it says list any angles that have to be congruent to angle G or congruent to angle U. So again, corresponding angles are going to be congruent. So therefore, angle G, which I know this is getting a little messy now, but angle G is the third one in right there. So the third letter is angle T. And angle U is the last letter. So the last letter on the left is angle H. So I'm going to let you try letter B on your own. And again, if you have questions about it, you can ask me in class, but it's very similar to question A. Then question C says triangle PQR and triangle LMN are similar. Write the congruence statements that must be true. So remember, when a figure is similar to another figure, the only thing that are congruent are angles. Remember, our sides are proportional. And so in this case, we have three angles. First one is going to be angle P, Q, and angle R. And since P is the first one on the left, it's going to be congruent to angle L. Q is the middle one, so that's congruent to angle M. And R and N. And that would be it. Those are the only things we can tell that are congruent because those are the only angles. Now, letter D, this is a different mapping problem. It says ABC maps to JKL. So again, there's that mapping to. This is going to be our start. This is going to be our finish or our end point. That's where we're going to end up. And it says, I want to start with XY. And then it says we're going to jump to X plus 2 and Y minus 1. And then ultimately end up at 3X and 3Y. And so in a problem like this, whatever happens here in the middle, we really don't care about. Ultimately, it's a matter of, this is where I started, that's where I finished, how do I get there? And really, what changed between when it started and when it finished? Well, what's happening between the X and 3X? You're multiplying by 3. Like, that's all that changes. So the X is multiplied by 3 and the Y is multiplied by 3. So it says if KL from our second triangle, if KL is 12, what does BC have to equal? Well, remember, BC is what we started with, and so we said that to get from our start to our finish, we had to multiply by 3. So what number would to have multiplied by 3 to get to 12? Well, 4 times 3 gives us 12. So BC would have to be 4. And then I'm going to let you try letter E and see what you guys can come up with there. It's a similar problem, a little bit different, but challenge you a little bit and see what you guys can come up with for letter E. Then lastly, we have our last example here. Properties of similar figures can be used to find corresponding parts. So it says that given that the figures are similar, so we're saying we know they're similar, find the values of x and y. So what do we know about angles C and R? Well, if you look, this ABC here, this quadrilateral right here, almost kind of looks like a trapezoid shape. Looks like it's been turned a little bit, it's been rotated, but they're pretty much the same shape. And so C actually corresponds with R, and since they're corresponding angles, we can say that angle C is congruent to angle R. And how does that help us? Well, since I know angle C is 4x plus 27, and angle R is 95, and they have to be the same, they have to be equal, we can set that up and then ultimately solve for x. So we're going to subtract 27 from both sides. 4x equals 68. Divide by 4. So x equals 17. So just like that, since I knew they were similar, I knew my angles were congruent, and then therefore I can make them equal and solve for the variable. Now the next problem says make a proportion of sides to solve for y. And so it kind of starts it off here and says AB and PS. So it says AB corresponds with PS. So what's another side from my first diagram here that I also know something about? So the reason they used AB is because it tells me that it's 4y. It gives me that measurement. And PS also gives me a measurement of 10. So what other side does ABCD have? Well, if you look right up here at the top, AD has 3y minus 5. And so AD corresponds with PQ. So AD and PQ. Now that we have a proportion set up, we can simply put in our values for AB, PS, AD, and PQ. So that's going to lead us to having 4y over 10 equals 3y minus 5 over 5. Again, use our cross product property. Take our top left and our bottom right. We're going to multiply there. So we have 5 times 4y, and then multiply the other two, equals 10 times 3y minus 5. 5 times 4y on the left is 20y. Distribute the 10. 10 times 3y is 30y. 10 times negative 5 is negative 50. 50 to both sides. So 20y plus 50 equals 30y. Subtract 20y. So 50 equals 10y. Divide by 10, and y equals 5. So again, that one's always a little trickier because with sides, they're not congruent, they're proportional, so you have to set up the fractions. Okay, two fractions equal to each other, and the trick is finding which sides do they give you, right? If they give you certain sides, you're probably going to want to use the ones that are labeled. Okay, so that'll kind of help you out with those. So for letter B, I'm just going to kind of get you started here and then let you finish B and C. For letter B, first of all, let's call this figure KLMNJ. What would this figure be called? So if we're starting at k on this one, which one looks like it would go with k? That would be w, right there, the kind of pointy part of it. And we went from k to l, so that little drop right there looks more like this drop, so we're going to go to x, and then we're going to keep going around our figure to y, to z, to v. And so from there, that might help us as we figure out which sides and angles to match up. In this case, for our angles, it gives us this angle right here, angle M, and this angle, angle Y. So M and Y, since they're in the same spot, those are corresponding, which means that they must be congruent. So 5 times x minus 5 has to equal 4x. I'm going to let you solve that one from there. And then to help you set up a proportion, again, look for sides that they give you. In this case, kj has 2x minus 8. So we're going to use kj. And kj is that long side, so that's going to correspond with wv. And the other one it gives us is mn. And mn corresponds with yz. So if we substitute in our values there, we would have 2y minus 8 over 4 equals 1.5 over 1. And again, I'll let you solve that one from there and figure out what x and y is. And then you can also do the same thing with letter C. Now with letter C, I highly recommend that you split these into 2 separate triangles. Okay, so draw one where one's bigger than the other one and see if that helps. See if you can relabel those 2 triangles and figure out where my similar sides are and where my similar angles are. And again, if you have any questions, please, please, please ask.